Hello guys, my name is Sakshi Singh and I am in 4th sem of my integrated course of MTech. I am pursuing my MTech from International Institute of Professional Studies DABB. Now this is the first internal paper. Now the first question is write an algorithm to accomplish the task for polynomial px given in the following table. Now the polynomial is px is equal to a n x to the power n plus a n minus 1 x n minus 1 plus up to a naught. Now the task is evaluating the polynomial px, divide a polynomial by x minus r. Now find the differentiation of px with respect to x. Now for the iterative approach, n multiply n plus 1 by 2. For divide a polynomial by x by r, n minus 1 into n by 2. Now the third one, n into n plus 1 by 2. And for the recursive approach, n minus 1 and n. Now the algorithm for evaluating the polynomial px with using brute force technique, that is iterative approach. Now the first step must be initialize the sum variable s to 0. Now the second step will be for each term of polynomial from highest to lowest degree, compute the value of the term by multiplying the coefficient with x raised to the degree of term. Now second is add to the computed value to the sum s. Now third is return the s as the value of the polynomial px. It is the iterative approach. Now come to the recursive approach, algorithm for the polynomial px using recursion reason. Now the first step will be, if the degree of the polynomial is 0, then return the constant value a naught. That is the value of the constant term must be is a naught. Second is otherwise compute the value of px if it is not if degree of polynomial is not 0, then compute the value of px recursively by the first step is computing the value of the polynomial of degree n minus 1 by calling the function recursively with the polynomial of degree n minus 1 as argument. And the second step is computing the value of the current term by multiplying the coefficient with x raised to the power degree of the term. And the third step will be add the computed value to the polynomial of degree n minus 1. Now at last the last step is return the value of the polynomial px. Moving forward, now we will find the algorithm of dividing polynomial px by x minus r. Now the first step will be initialize the quotient polynomial x and remainder r to 0. Now the second step will be for each term of the polynomial from highest to the lowest degree. Now the first step will be compute the value of the current term of the quotient by dividing the coefficient by x minus r. Second step will be add the computed value to the quotient polynomial q. Now third option is compute the value of the current term of the remainder by multiplying the quotient of the current term with x minus r. Now the next step will be subtract the computed value from the current term of the polynomial. Now the last step of second step is add the computed value to the remainder polynomial r. Now at last step will be return the quotient q and remainder r. Now algorithm for computing the derivative of polynomial px. Now first step will be initialize the derivative px polynomial d to 0. Second step will be for each term of the polynomial from highest to lowest. First step will be compute the value of the derivative of the current term by multiplying the coefficient with the degree of the term and subtracting 1 from the degree. Second step will be add the computed value to the derivative polynomial d. Now the third step will be return the derivative value to d. Moving forward to the second question, that is write the algorithm and flow chart of the following task and complete the table. Now the task 1 is to subtract the value n1 to the value n2. and first data 1 is given and data 2 is also given. So we have to write the error message as well as the final result. Okay, so in the task section we have to do subtraction as well as multiplication and division also. Here it is n1 divide sign, so it will be multiplication. Now when we subtract n1 by n2, we will get the value something near to the value 0.028 r to the power minus 99. That is in the negative. The power is negative. When we see the exponential part of n1 and n2, we will find that both the exponent of both the number is same, so we will easily solve it, and we get the message underflow. Now at the second question, when we look at this, we will find that the final result will be 0.2800 e to the power 1. It is by changing the negative power to the positive. Now the second one is multiplication, that when we multiply number n1 to the number n2, so when we multiply n1 and n2, we find that the power exponential part of n1 is 151 and of the second one is 50. So when we multiply both the number, we will find that the answer will be 0.4937 e to the power 100, and it will be overflow value. It gives the overflow value, that is more than the space that are there in the memory. And data 2 will show 0.1370 e to the power 24, and error message will be loss of 0.974. Now at the division part, when we divide n1 by n2, we find that the exponential part of n1 is 1, and of the second number n2 is minus 99. Of the end of the second data, the exponential part of n1 is minus 5 and of second number is 98. So when we solve, we find the value of data 1 is 0.0998 e to the power exponential part is 101, and it gives the value, it gives the overflow value. And in the second data, we will find that 0.998 e to the power minus 104, that is underflow. Now by doing this, we have to keep in mind that the significant and the round off of the final answer to appropriate answer to significant figure. However, since the question does not specify the number of significant figure with any rounding, we can round the number by any number according to our choice. Now moving forward to the third question, that is verify associative law and distributive law of arithmetic with fitting Manthisa digit and provide correct answer if no number is truncated. Now as we know that associative law is if associative law over multiplication is, then it is something like a into in bracket b into c, that is equal to a into in other one bracket, and outside the bracket there will be sign of multiplication into c. Similarly, distributive law will be like a into, if there is an equation like a into b plus c, then in RHS its value will be a into b plus a into c. Now the value of a is given is 0.5665 e1, b is 0.556 e to the power minus 1, and c is 0.5644 e1. Similarly, there is some value given to the second question. Now case 1, that is the first case, to verify the associative law and distributive law of arithmetic with fitting 4 Manthisa digit, we need to perform the operation on the given value and check if the result satisfies. Now the LHS value we will get is 0. By applying the formula a plus b minus c, we will get the value 0.0076 E1, and by applying the formula at the right side, that is a minus c in bracket plus b, we will get the value 0.7656 e to the power minus 1. So both the values are not equal, so it does not follow distributed law. Neither both the value will not follow, the given value will not follow associative law. Now come at the case second, when we put all the value in the given formula, that is a minus b minus c is equal to ab minus ac, we will find that again value is not equal at the LHS and RHS, so it will not follow distributive law. So since no law hold of this value, we can provide a correct answer without truncation. Now coming to the fourth question, that is true or false. Now the first question is minimize the number of arithmetic operation whenever possible. So it is true. We can minimize the number of arithmetic operation whenever possible. There are several reasons why it is beneficial to minimize the number of arithmetic operation whenever possible. The first one is efficiency, second one is accuracy, third one is robustness, and fifth one is memory uses. So the first statement is true. Now moving to the second statement, that is avoid taking the difference of two nearly equal number whenever possible by alternate formulation of the problem. If it cannot be avoided, take the difference before doing other operation. It is also true. If we take two number a and b, that is two nearly number, so when we subtract both the number, we will find that there is very little difference, very small, due to limited precision floating point arithmetic. This can lead to inaccurate result and numerical instability, especially if C is used in subsequent calculation. Now moving forward to the third option, that is adding or subtracting numbers, start with the smallest number and work with the number in ascending order. We will find here that this statement is also true, as by adding the smallest number, working with the number in ascending order can help the improve of accuracy, numerical stability of the calculator. There is example, I have taken example, that is when we take a value, a is equal to 1.27, b is equal to 0.0, c is equal to 40.67, and d is equal to 0.0005. If we add this number in ascending order, we will get that value will come, that is equal to 46.9035, and when we add this number in ascending order, we will get the same number. So overall, adding or subtracting number starting with the smallest number or working with the number in ascending order can improve the accuracy and numerical stability of the number. So moving forward to the fourth statement, that is do not formulate an algorithm that tests whether a floating point number equal 0. So it is here, it is given that it is not recommended to formulate an algorithm that tests whether a floating number equals 0 because floating number are not exact and the value may be subject to rounding error. Due to the limited precision of floating point arithmetic, it is difficult to represent certain number exactly including 0. This means that even if two floating point numbers are mathematically equal to 0, their representation in memory may differ due to the rounding error. Okay. Now moving forward to the fifth statement, that is conditioning of problem. If conditioning of problem is normally due to the improper formulation and can be eliminated carefully, reformulating the problem. A practical way, if detected subtracted ill conditioning, is to alter the parameter by small amount and observe their effect of the solution. This statement is also true. After a numerical algorithm is obtained, check if it can be lead to numerical instability. In such algorithm, error group in each step of calculation In such cases, reformulate the question procedure to get the stability numerical algorithm. The given statement is also true. So the answer will be true. Now moving forward to the seventh question. The statement given is, if severe rounding error and consequent loss of significant digit are anticipated and no alternate formulation to avoid this is possible, then carry more significant digit in the critical calculation using floating point number in double precision mode. In this mode, the length of matrix is twice as the other floating quantities. It is true. By doing all this alternate formulation, no alternate formulation to avoid the possible carry more significantly, we will find that the length of the mantissa will get twice as the other floating point number. So it is the true statement. Moving forward to the eighth statement, that is, double precision require large memory space and slow down calculation. That is exactly true, that when the number is very large, then it will take large memory, and by doing any calculation over large number, of course take loss of time as compared to the small number. So this statement is also true. Now the ninth statement is, in the third iteration of finding the square root of 5 with a starting point 7 using the Newton-Raphson method, relative error is 0.03. Coming to its solution, we will find that if we have assumed some formula for finding the square root of 5, that is xn plus 1 is equal to 0.5 multiply xn plus x divided by xn. So by applying this formula, we will get that x value is 0.2419. The third approximation of the square root of 5 using will be starting point of 7 and the relative error of 0.09 is approximately 0.24119. Now we are on 9th, so this statement is also true. Now moving forward to the 10th question, that is, the iterative method are compared on the following parameter. Yeah, this is true. That is depend on the rate of convergence, the amount of computable effort per iteration, and the third one is the sensitivity of the method to the starting value and the intermediate value. Thank you so much for watching my video.